LeetCode Problem number 90, subsets 2. So this problem gives us an integer array called nums that may contain duplicates, and we have to return all the possible subsets of this nums array. And the important part is that the solution set must not contain duplicate subsets, and we can return the solution in any order, right? Okay, so what this means is that for example, here we have 1 to 2, so we have to return a list containing all the subsets, which in this case would be a empty one, 1, 1, 2, 1, 2, 2, 2, and 2, 2, right? Because we can include duplicate numbers in a single subset. Like this is a valid subset, but we cannot contain 2. For example, we have 1 to 2 twice appear in our result. Well, in what we return, basically, I call it result. Okay, so my solution to this problem is to use a backtracking method by using recursion. And on top here, I have the result. This is the 2D vector that we are going to return. And here I have the current, which is a 1D integer list. This current is what I will be pushing into result, and this result is what I will be returning as the answer. Okay, so in the main function, I first sort the number. So the reason to sort the number is because one of the test case, for example, will give something like this, right, 212. And by sorting the number, 122, here I can just check whether or not we have accumulated a similar number in the past before in our backtracking method. So we do not need to push it into result again because we cannot contain duplicate subsets, right? Okay, so that's the reason behind the sorting. Let's start with an example. Let's say my nums is 212. So what I do first, like I mentioned, is I sort the nums. So nums will now become 122. And then I enter the recursion. So I'm passing in nums is what we are giving. Nums is what we are given, and 0. So 0 is the starting index. Result, and then current. Okay, so we have index, which is currently 0. So the first time we call it, we straight away push into our result current, which is currently empty. Okay, and then we enter a for loop. So I is equals to index, which in this case is 0, while I is less than nums. So we are iterating through nums with an increment of I++. So here we can just skip first because I is not more than index, they are both the same. So what we do is we push back nums I into current. Nums I currently is 1. So we push back 1, and then we recurse again. So in my recursion, I'll use a bracket. So our index is equals to I plus 1. 0 plus 1 is 1, right? Okay, so we push back our result. We push back current into our result. Enter the for loop again. I equals to 1. Does not trigger. Current push back. Push back 1. 1 is 2. Recurse. So index now equals to 1 plus 1 is 2. So we push back our result. And then enter the for loop again. I equals to 2. Does not trigger. Push back nums I into our current. Now 2 is this 2. We push back, recurse one more time. X equals to 2 plus 1. This case is 3. and then we push back current into our result once again. Now here, since index is 3, and when I is equals to 3, I is no longer smaller than num size, right? Num size is now 3, and 3 is not smaller than 3. So this for loop is not entered, so we can just immediately close this recursion. Once we are done with that, we exit from here, from the previous recursion function called, and then we pop back. After we pop back, we increment our I. Now we check, right? Actually, when we increment our I, we do not enter the for loop anymore because 3 is no longer lesser than num size. So the same thing, we close this function, exit from here, pop back again, and then increment I is now 2. Okay, now we can check, right? So I is now more than index, right? 2 is more than 1, and nums I, this, is equals to I minus 1, which is this, right? So they are the same numbers, so we can just skip it. We don't need to run the rest of this code, and we just increment I again. And when I reaches 3, this for loop ends, so we terminate this recursion. When we do so, this recursion will be exited, and then it will pop back this, right? Okay, now once we're done with popping back, so we increment our I. Now we check if I is more than index, which it is. We check the numbers. 1 is it equals to uh, index 0? It is not, so we don't need to skip. And then we push back current, we push back nums into current, which is 2. Recurse, so index is equals to 1 plus 1, which is 2. Enter, oh, not yet, we push back current into result. Enter the for loop. This does not trigger because I is equals to 2. Push back nums into current, I equals to 2, so we push back this into current. Recursion again, 2 plus 1 is 3. Push back current into our result. Since index is 3, we do not run this for loop, so we just immediately terminate this function, this recursion call. Exit from here, pop back. Once we pop back, we increment I. Once I is 3, this for loop will not run again. So when we terminate, we exit from here, pop back again. Then we increment I to 2. And now we check, right? If I is more than index, it is. And then we check whether or not I, 2, is the same as the number before it. Since they are both the same number, we just continue. Now let's say if we do not check for this, what we will do is we will push back 2, which we have already visited right over here. And then when we recurse into it, we'll be pushing this into it as well, right? This is not what we want. We don't want to revisit what we have visited. So that's why this if statement is here to check whether or not we have revisited. We have visited that path before already. Okay, so since this is since we are continuing, I will increment to 3. When it increments, this loop will end, and then when it returns, it exits here and return our result, which is here. You can see it's the same as the output given in the example. Okay, obviously the content of result can be in any order, but it just so happened that they are the same now. So all in all, a pretty straightforward solution. Hopefully this is sufficient. That's all I have to share. Thanks.